today's session, we are going to understand that what is CNN and what is RNN. So CNN is a convolutional neural network and RNN is a recurrent neural network. So first, we again understand that what is neural network, and in today's session, we are going to discuss how CNN and RNN work, and what are the different applications of CNN and RNN, and what are the different key differences. Because the main important part is for which type of the data set, which algorithm gives you the best results. Okay. So we already discussed that a neural network is a computational model that is inspired by the human brain, and it has a multiple layer like input layer, hidden layer, and output layers. And each neuron in a layer is connected with the other neurons of the next layer. And neural network recognize the patterns and make the prediction on the basis of the data set provided to the neuron. And it also provides the techniques of the back propagation so that we can learn from our mistakes. Okay. So what is a convolutional neural network, CNN? So basically, CNN are specialized for processing the structured or the grid-like data set. So if you have any images, for example, when we talk about the medical field, in the medical field, when we are discussed with the various types of the medical images, like the mammography images for detecting the breast cancer, for the means brain cancer, and for the cervical cancer. There are different types of the cancer, and we have the technique that is a images of the mammography. So how to analyze that images? In that cases, the CNN gives you a good results, because CNN takes the input in the form of the images. I am not saying that the ANN is not taking the images as a input. It also takes the images as an input, but the CNN gives you the good result as compared to the ANN if the input data is in the form of the images. Okay. And this CNN use the conventional layer to detect the spiral hierarchies in the images, and it also reduce the number of parameters. Okay, so in the images, we know that there are lots of the parameters are there to analyze. Okay, so basically CNN reduce the parameter so that the processing is fast as compared to the ANN. Okay. Then what is the architecture of the CNN? Basically, CNN provides you architecture where there is a conventional layers, and the work done by the conventional layer is to extract feature from the input images using some filters. Okay, so there are some filters, and these filters work is to extract only the important features from the images. And in this way, the number of parameters in the input images are less as compared to the normal methods. Okay. Similarly, next in the conventional neural network, there are some pooling layers, and the work of the pooling layer is also to reduce the spiral size of the feature maps. Means the size of the matrices that the computer understand, and the size of the images is less. Okay, as compared to the conventional methods. Okay, now the different layers in the CNN architecture is a fully connected layers. Okay, so at the time of the classification, it only flattens the extracted features from the classification, not using all the features. Okay, so we have to understand that if the structure of the neural network is a fully conventional neural network, then the processing of the images is fast, as well as the time to process the images is also less. Okay, so basically mostly researchers are using the conventional neural network or CNN when they want to analyze the different images. Okay, now how does CNN work? So basically, CNN work in a totally conventional operations, means using the filters to detect the edges, textures, and patterns from the images. And on the basis of that, it decide that which particular edge gives means takes part in the classification, and if the edges are not matched, then these data is not used in the classification. And as we already see in the ANN that there are we require some activation function. So here also ReLU into activation function is introduces, and it used for the non-linearity. Okay, and for predicting the output, it using the pooling method, or pooling is done by two ways: either it's a max pooling or it's a average poolings, and it only retains the essential features that is required for the classification. Rest of the features are filtered by the convention layers. Okay, so what are the different applications of this CNN? Where, as we already discussed, that applications of CNN are in the image classification. For example, object detection, facial recognition. For example, you have to the traffic, you have to analyze that how many two-wheelers, how many four-wheelers are there. In that case is also CNN is used. But yes, for the object detection, YOLO algorithms are the best as compared to the CNN. It also used for the medical imaging, that is a disease detection from X-ray images, MRI images, etc. Mammography images also, and it also used in the autonomous vehicles for detecting the real-time objects. Okay. Now, how what is recurrent neural network RNN and how it is different than the CNN and ANN. Okay, so basically RNN handles sequential data. Okay, where order matters. For example, the time series analysis. For example, the speech recognition, where the order of the words is important. For example, the new text generation, for example, the chat GPT generate a text for us. In that cases, we required a sequence of the word in a right way. If the sequence is disturbed, then the meaning of the sentence is changed, and in that cases we can use the RNN when we required a sequential data to handle. Okay, so basically it use feedback connections, allows information persistence. So it allows you to arrange the output in the form of the some sequential data. Okay, then what is the architecture used by the RNN? So basically, RNN uses again the three layers, that is the input layer, hidden layer, and output layer. And in the input layer, we provide the sequences of input. In the hidden layer, we process the current input with the previous hidden state, and output layer produces your sequential outputs. Okay, and RNN already maintained its internal memory for the context-based predictions. Okay, because when we are arranging the data set, it is important that we require to maintain the internal memory. If we don't maintain the internal memory, in that case, the problem is we don't arrange the data in the sequential order. Okay, so that's why we require to RNN to maintain their own internal memory for context-based predictions. Okay. Now, how RNN works. So basically, RNN process input step by step and maintaining the hidden state as uh, required by the data set, sequential data set. And it also learned the temporal dependency in the sequences, means how the one word is dependent to the another word. If there is a dependency of one word is very high, it means that word affects the majorly affect the whole content. Okay. And in that cases we have to use the internal memory for arranging the data in a sequential order. Okay. 1 second, please. Okay. So basically, RNN faces challenges because if there is a dependency of one word is very high, in that cases, if the particular word uh, don't store properly in the internal memory, then it faces the challenges like the vanishing the gradient problem. So this is a problem in the RNN. Okay. Now, what are the different types of the RNN? So there are various varieties of the RNN that like vanilla RNN, LSTM, that is very popular, and the GRU. Okay, so vanilla RNN has the basic structure with the simple hidden layers. Okay, and LSTM addresses the vanishing gradient problem with memory cells. Okay, and the JRU is used as a simplified version of the LSTM with the fewer parameters. So it totally depends on you. Uh, it's totally depend on you that which type of the RNN gives you a good result. Okay, so depending on that, you can use the different varieties of the RNN. Now, what are the different applications of the RNN? So RNN is majorly used in the NLP based application like the chatbots, translation of particular sentences, and in the sentiment analysis that is used by the various platforms. And it also used in the speech recognition, that is how to convert a spoken language into a text. And mostly this LSTM model is used in the stock market prediction, and that analyzes the historical trends. Okay. Now, how we can compare the RNN and CNN, and how we can recognize that which uh, type of the neural network is good for which type of data set. So basically, this ANN is used for the numerical or the categorical data set, but the CNN is used for the images, and RNN is used for the sequences. The processing of the CNN is in the form of the spiral data set, and RNN is in the form of the temporal data set. And obviously, the architecture of CNN is a convention layers, and the RNN is a recurrent layer that have the internal memory also. And the use cases are the CNN is the image recognition, and the use cases of the RNN is a speech and text processing. Okay, so basically, CNN excel in the spiral data, like when we have to process the images and the videos, while the RNN handle the sequential and the time dependent data set. So deep learning is evolving with the hybrid model also, where you can combine the CNN and RNN also. It depends totally on your use cases, that how you can make a hybrid model to analyze the data set. Because if your data set is a temporal data set, means time dependent data set, as well as data set is in the form of the images or the video, for in that cases you can combine models and make a hybrid model and perform the analysis. Okay. So in the yesterday session, we are facing problem because when I am downloading this Keras and TensorFlow, it takes lots of time and bandwidth. So for that, first means I already downloaded all the required libraries so that we can run the code very smoothly. Okay. Now this file I already shared with you. Okay. So in this data set, I am using this ANN algorithm for classifying the iris data set. So what is iris data set? I first explain you. So iris data set is actually a category of the flowers on the basis of four things. That is uh, on the basis of the length and the width of the petals and length and width of the sepal. Okay, so you can directly download this data set also from the kaggle.com, and just you have to type this iris data set and you get the file. Okay, but in Python, I already told you in the yesterday session that in Python we have some inbuilt data set also. Okay, so if you want to use the inbuilt data set, the loading of the file is not done, and the program takes a less load as compared to the uh, when we are using the uh, CSV file. So if the data set is already available in the Python, we don't require this data set in the form of the CSV. But yes, if you want to download, this is a data set and you can download from here also. So what is the size of the data set? The size of a data set is a 150 by 5, means there are 150 rows, and there are 5 columns, in which the 4 columns are the independent columns and the last column is a dependent column. Okay, so I already I'm going to share you the link. So if you want to download the data set, you can download. Okay. So, but I am using here the inbuilt data set. Okay, only. So in this data set, you can see that I first load this iris data set and then make two things: independent column and dependent column separate. So X is my independent column and Y is my dependent column. And if required, then you can use this label encoder and transformation of the data set for data pre-processing. Then what we have to do, we have to split the data into a training testing part. And here I make a test size 0.2. You can take any text size, but mostly researchers are using a 70-30 ratio, means 70% data is a testing training data and 30% data is a testing data. Okay, but it totally depends on the size of the data set, means how you can separate, means make a split the data set into a training and testing part. But make a note always that training data set size is always greater than the testing data size, because the training data sets is used for the building the model, and testing data is used for testing the accuracy of the model built by the training data set. Okay, so we have to check that what ratio we can use, and for splitting the data set we are mostly using the random sampling. Now we have to build the ANN model. So we have to make three layers. One is the input layer, second is the hidden layer, and third is the output layer. I already told you in a yesterday session that the number of layers is totally depend on you, means how many input layer and the hidden layer you want to make. But yes, don't increase the size of the hidden layer unnecessarily, because if the number of the hidden layers are high, then the problem is the model is very complex, and the time to build a model and time to compile the model is high. Okay, now I want to explain you why I use here the output layer 3, because when you check the data set and you see the last column where there is a species, means which type of the species of the particular flower, you get a three values, means the total data set has only three different classes. That's why I use here three, because if the in the data set there is only three classes are there, we cannot make more than three classes in the our model. Okay, and after that we have to compile the model, and for the compilation we use the optimizer, loss function, and the matrices that I already explained you in the yesterday session. And now I want to explain you what is epochs. This is very important. So when we are fitting the model or when we are training the model, how many times you want to take data set and validate the data set. Okay, so in machine learning, mostly we are taking input one time, processing one time, and output also get one time. But in the deep learning algorithms, we can take a sample of the data set and we can make a model multiple times, and on the basis of the max pooling method, either it's an average or max method, we can find the accuracy of the model. Means we are building model not one time, we are building model many times. So what is epoch? How many times you want to train the model. Okay, so you can increase or decrease this value. So for example, if I make this 5, okay, so it trains the model 5 times. And on the basis of that, it evaluates the accuracy and the loss of the model. Okay, now I'm going to run this code. So it takes some time because it is loading the data set first from the using the internet, and after that it is making the model, transforming the data set, train the model, and find the accuracy. It takes some time, so please patiently see that how it is worked. So you can see here, this is epoch 1. So this is epoch 1 out of 5. Please understand the result first. This is epoch 1 out of 5. So here I take value 5. So first trains the model. Okay. How many times? It takes a 4 data set, and out of that it finds that the accuracy is a 0.63 and the loss is a 0.98. Okay. In the second time epoch, it gives you the accuracy, that is a 0.59, and the loss is a 0.7. Similarly, third time, fourth time, 5 time, and by either making average or by making pooling. For example, in all the cases, first is a 0.63, second is a 0.7, third is a 0.737373. So what this max pooling method do? What is which accuracy have the maximum times come while train the model? So what value we get? We get the value 0.733. So the final accuracy of the model is a 0.733. Okay, understand everyone? If you have any query, then you can write in the chat box so you can understand that how these algorithms are run and how you can evaluate the results. Okay? Yes. Okay. Now let understand that how it is different than the RNN or first the CNN. Okay. Okay, so I already explained you about the one data set, that is MNIST data set. That is a data set having the handwritten images of digits 0 to 9, and how these images are used in the CNN network to create a model and to find the accuracy of classifying the digits 0 to 9. Okay, so again, we require the TensorFlow, we require the Keras library, and uh, if we can do large number analysis or large number handling, then we require also a NumPy, but I am not using NumPy here. Okay. So what is this MNIST dataset? That is already inbuilt in the Python. So I am not using CSV file. I am directly loading this dataset. Okay. So again, what the steps we have to do? First, we have to load the data set. Then we have to pre-process the data set. Okay. So for pre-processing of the data set, we required a data set that is divided into a training and testing part, and then normalize the data set. And for normalization, we are using 255 by 255 matrix. So we divide the training and independent data, training and testing data by 255. Okay. Now we can reshape input. Okay. So why reshaping is required? Because we don't want to increase the number of the parameters. So in that cases, you can reshape the data set. For example, the data set that we are using is having a matrix size of 255 by 255. Okay. And I want to reduce that matrix size by 28 to 28. Okay, you can take any size, but means you have to do error and trial that for which size the algorithm gives you a good result. And I also reshape data, means all the data set that is available in the matrix as a value having the range between -1 to +1. So handling the data set is easy, as well as it takes a less time as compared to the ANN. Okay, so the reshaping is also required. Okay, it is not compulsory, but if you reshape the data set, then the processing of the algorithm is fast. Okay, now to create the CNN model, you can see here I make a one function. Okay, so what do you have to do in the CNN model? Again, there is a three thing. First, making the input layer. Second, making the hidden layers, convention hidden layers. And third, making the output layers. Okay. So for making the input layers and the hidden layer, here it is using the conventional 2D network. Okay. We can use a 1D also, 2D also, and 3D also. It depending on the type of the data set, because the images that are available in the MNRST data is a 2D images. So I am using a conventional 2D model here. Okay. Now I am making here 32 input layers having the kernel size 3 by 3. Okay. So what is kernel size here? Basically, kernel size is how you divide this 32 layers. Okay. So these 32 layers are giving data from one to other layer and making the kernel size 3 by 3, and that is all the data in the form of the matrix. And for that, I am using the activation function, that is REL. Okay. And to take the extracted features from the input layer, I am using here a max pooling 2D method. There are lots of the method available. Averaging method is also available. But this max pooling is that the maximum value or the maximum time the value get from the model is used further. Okay. And I use here the pool size 2 by 2, means if any value comes in a matrix minimum 2 times, I can use that as a max pooling value. Okay. Now to make the hidden layers, I am using here the again 2D model, because if you are making the input layer 2D, then it's compulsory that you have to make the hidden layer also 2D. And here I make a 64 hidden layers. Why? Because I make a hierarchy of 2 steps, 32 in the first step and 32 in the second step. Okay. So and all the layers, all the nodes are connected with each other. Okay. Again, it is also doing the filtering, so I am using the max pooling 2D method. And for finding the output, I am using the dense model. And for that, I am using the activation function RELU, and here I pass the number of classes, means the number of classes that are available in the data set. For example, in the iris data set, how many classes are there? There are 3 classes on. So it takes the number of classes from the data set, and only um, that number of the output layers are defined by the method. Okay. Now, similarly, as we do in the ANN, we have to compile the model. Okay. And this is a method. So I return the model. So here I am creating the model by calling the function. And here I take a epochs of 5. You can increase or decrease epochs. Okay. And for making the model, I using the training data set, X-train and Y-train, but for validating the model, I am using the testing data set. Okay. So here you can see that validation data is a X-text and Y-text. Okay. So it totally depends that for creating the model, we have to use the training data, and for testing the, for validating the model or testing the accuracy of the model, we can use the testing data. Okay. Now we can evaluate the model by using this evaluate method and find the accuracy of the model. Okay. Now I am going to run this data set. It also take some time. So please be patient. Okay, so it is running. If you see, the first epoch is running, and there are 1875 images are there. 1875 columns are there. So it compiles each and every column. Please see how these results are processed. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . It takes time. If your processor is fast, it takes very less time, but I don't have the latest processor or the processor, good quality processor. That way it's take a time to process all the columns. And for all the epochs, it do the similar thing. And for all epochs, it trains the model, find the accuracy and find the loss. And on the basis of the maxful method, it return the accuracy of the trained model. Yes, where you find this loss and val loss, actually that is a variable. I don't understand where you can find. If you guide me, then I can explain. Because actually this loss is a keyword argument that we can pass in the method, where we have to uh, pass that which type of loss we are including in the model. And to store that loss value, we can take a variable to store that value. You can see the first time it process all the 1875 columns and find that the accuracy, this val underscore accuracy is nothing. It's a way to return the value of the accuracy by the model. Okay, it's just a type of the means way to return by the inbuilt model, because we are using here inbuilt models. We are not making our own model. The models already available with the TensorFlow library, we are using the same. Okay, you can see that for if the data set size is very large, in that case the processing time is also increased. Actually the accuracy is depend on your use cases. For example, if we are processing the data set, medical data set, in that case you know that if the accuracy of the model is 97%, 96%, in that percent there are 4% error. So 4% error means we are not detecting or we are not classifying the image correctly. In that cases, we required a good accuracy value, for example, 99.9%, 99.8% in the medical cases. But when we are dealing with some other problem where the precision is not required, in that cases, you can compromise with the accuracy of 96%. Either you can compromise with accuracy of 85% also. So it totally depending on the use cases, for which use cases you are training or testing the model. Okay, so we can see that in the first EPOS value, the output, that accuracy is 0.9820, and in second case 0.9867. In third, the accuracy is 0.989914. Okay, you are telling about this accuracy and this accuracy, I think, na? Okay, so we can see that when we are choosing data set for building the model in all the cases, it might be possible the data set that is covered in the first case is also in the second case. And it might be possible there is a biasness, means the data set choose by the random algorithm having some bias. So in that cases, this val accuracy also include the biases made by the algorithms. Because when we are taking the data set with the help of any algorithm, that it totally depend on the algorithm that which data set is in the model. Okay, so there are some biasness also made by the algorithms. Okay, so it takes a time. Now it's run the fifth EPOS value, and it might be possible the output of my system and output of your system is different, because the random data that is chosen by my system and the chosen by your system is different. Okay, because this is a random sampling algorithm, so it might be possible there are differences in the accuracy value. But yes, if you want to fix the accuracy, or if you want to fix that every time you want to get the same data and also using the random uh, sampling, then there is a one method that is called a seed method. You can pass the seed value, and if your seed and my seed is same, in that cases yours and mine's output are same. Otherwise, every time when I run this code, I get the different output. Okay, so finally it gives the 98.99% accuracy. Okay, as a max pooling method. So it in that cases 0.9899 occurs maximum time. So it you using the pooling method and gives you that accuracy. Okay. So I am sharing this code with you. So if you want to run in your system, you can run and check the accuracy and the loss values. Okay. Now, if we want to build the same CNN model for the CSV file, then how to do that? What are the changes you have to made in your code? That I am going to explain you, because when we are processing the real-time data, we have the data in the form of the CSV files. Okay, so in that cases, we cannot use the inbuilt model. So how to process the CSV file, I can explain you. So I am using the same file that I shared you yesterday. That is a heart.csv file. Okay. So here the path of the my file is changed. So I first change the path so that my program run without any error. So this is a hard.csv file. What you have to do, you have to right click, go on the properties, and just take the full path. Okay. And you have to just paste it. You have to change these slashes. Okay. So in this hard.csv file, we know that the last column, I already explained you yesterday that the last column is the output column or the target column that having the dependent values, and rest of the column has the independent values. Okay. So why this -1 is used? -1 is used for extracting the last column from the data set. Okay. So here we are using the data frame concept and extract the last column. Now we have to make this X and Y. So if we drop this last column or the target column from the data set, we get all the independent data in the X variable, and the last column that is already stored in the target column variable is our dependent data set, or we can say is our target data set. Okay. Again, same thing we have to use. We have to pre-process the data set. And for pre-processing, we are using a label encoder, and we are using a standard scalars for processing the data set in the form of the -1 to +1, means standard scalar is used for the Z transformation. Okay. And Z transformation, why Z transformation is used? Z transformation is used to standardize the data set so that the data set follow a normal distribution. Because if the data set is normal, then in that case, the results of the algorithms are good as compared to the non-normalized data set. Okay. Now, what we have to do, we have to separate the split the data set into a training and testing part. I again use here the test size 0.2. Now I want to change, my change is 0.3. So what this means, 70% data is a training data that is used to build the model, and 30% data is a testing data that is used to validate the model. Okay. Now we can reshape the data set that we already do in the CNN model, but here I am not using the 2D conventional model. I am using a 1D conventional model because we don't have the images. When we have the images as a input, in that case, we can use a 2D model because every images is a two-dimensional data structure that is in the form of the row and column. But when we are using this data set that is in the CSV file and in the form of the columns, then we cannot use this conventional 2D network. We have to use this 1D network. Okay. So here I am first I am making this input layer. Okay. Second, I am basically using this max pooling method. Now the flatten the layers and then dense the layer. Okay. And how many output layers we have to use? Here I use a numpy, and np.unique y means for every unique value in the output variable. Okay. Y. So in the y, if you check in the hard.csv, there are only two values, 0 and 1. Okay. So it means it makes a two output layers. Okay. Now again, I compile the model, then train the model using the training data set, then fit the model. And here I take a EPOS of 10. Okay. So I reduce that because it takes a lots of time to run. I make it 6. So if you don't get the accuracy as per your requirement, in that time you can increase and decrease the EPOS and check how the system, how the algorithm can work. Okay, and for here also I do a one modification, that I also show you that how this precision is calculated. So accuracy and precision, both values I want to print. And for the precision score, we have to use any method, means how precision is calculated. So here I use a weighted method to calculate the precision. Okay. Now I am going to run this code. So you know that there are only 23 columns in the data set, so processing is fast. But in the MNIST dataset, there are 1875 columns, then it takes a lots of time to process. And it gives you a accuracy of 81.17 and precision of 81.90. So if you are not satisfied, so for example, I make this 15 and check that what are the changes in accuracy and precision. So you can see that when the epoch size is 6, at that time the accuracy is 81 point something and precision is also 81 point something. But when I increase the epoch value to 15, the accuracy and precision is high, because we train the data multiple times, and from the max pooling we get the accuracy and the precision. So you can customize code accordingly, means which value means up to which value you can satisfied with the result, and if you don't satisfy with the result, you can make changes in the algorithm, and you can get accuracy as per your requirement. Okay, understand? Now I'm going to share you this code also. Please run these code in your system, and if you are finding any problem, then you can uh, share me the error. Yes, we can generate the accuracy and precision losses. But we cannot generate the accuracy and the loss table by the Python code, because actually these are not the values in the Python, these are the object in the Python. Okay, so we have to manually put these values in the table. But yes, if you want to generate the confusion matrix to show that how this accuracy and precisions are calculated, then you can do with the confusion matrix. So that is already available in the sklearn library of the Python. Okay, because this accuracy and precisions are calculated with the help of the confusion matrix only, where there is a positive, true negative, and false positive, false negative values are there, and the formula is used to calculate the accuracy, precision, recall, and F1 score values. So mostly in the research papers, people are not showing these all the accuracy values. They are only showing the final accuracy value, and they are comparing that accuracy with the uh, uh, different comparison with the different algorithm with the same input, and all the parameters are same. For example, I am comparing that which algorithm is more suitable for our data set. Either it's a ANN, either it's a CNN, either it's a RNN, because it is not compulsory that RNN is only used for the temporal data set. We can use for the image data set also. Okay, so we have to compare the different algorithm for the same output and same parameters. And if you want to show, you can show, but we cannot means store all these values in a variable. You can search my profile in the research kit, where you can find there are lots of the research papers are available, where we can compare the same data set for the different algorithms. And finally, we are going to give a conclusion that this data set, for this data set, which algorithms give you better accuracy, so that in the future or in the real time application, the people can use that algorithm for the reference. Okay, now I am going to explain you the RNN also. So for the RNN, I take a one sentiment analysis data set, and in Python uh, there is a inbuilt data set. IMDb. Okay, so you can search that what is this IMDb data set. But this IMDb data set is a inbuilt in the Python, and that is used for the sentiment analysis. Okay, 1 second. In Kaggle, there lots of the practice data set is available. But yes, you when you are searching, please search by the algorithm also. Otherwise, you can get confused that it might be possible the data set is not supported by the algorithm. In Kaggle, you get lots of the data set. Also, there are lots of the Indian government websites where there are data set is available. For example, the data.gov.in. You can also use that data set, but mostly the data sets that are available in the data.gov.in are not processed data set. We have to first do the pre-processing to make the data set usable for the algorithm. But in Kaggle, both type of the data set is available, pre-processed data set as well as the data set where pre-processing is required. So first, when you are practicing, please use the uh, text means pre-processed data set, so you get confidence, and after that you can use the unprocessed data set. Actually, you can write a script also, where you can do a text analysis and remove the inappropriate words from the text given by the user. And for that, you can use R programming also, and you can use Python programming also, and you can write your own script. And for that, you don't require a deep learning algorithm, because you are only, if you only want to remove the inappropriate words, in that case you have to make your own dictionary. And in basically there are lots of the dictionaries already available in the Python and the in and R for the language specific. For example, if you are taking any sentence or comment from user in the Hindi, so Hindi dictionary is of inappropriate word is defined, and you can use that library or the that dictionary to find the inappropriate word. First thing, you can do this also. The second thing, you can make your own dictionary also. So mostly in the research purpose, I have to check. I will tell you that which library is there, because I have one program where I uh, remove this inappropriate words in the R programming, not in the Python. Okay, but I will tell you sure tomorrow that what are the different libraries or available, and for you can use to remove the inappropriate one. But sure, for that you don't require the deep learning algorithm. Okay, so I am going to explain you the RNN for. Yes, we can do, but for that we have to make a one interface. Actually, if you want to give image as a input, and you want to predict in real time that this, either for example we are detecting a cancer and we want to predict that the what are the how many percent chances that this mammography image has a person has a cancer or not. So we can do that, but for that we have to develop a one interface. Either you can use a PHP, either you can use a Django language. For example, if you are trained the model using the Python, that the Django is a good platform where you can make a one interface, user interface, and user can enter the image, and there is a one tab uh, in which when we click, then this whole code is run, and it gives you a output. Okay, but yes, that is not only possible with the Python, that is possible with front end and back end both. So we in that Python work as a back end, and you required one front end also. Yes, we can do. Actually, that is means possible without interface also, but the problem is that for one image, uh, uh, you can use a input, only one input is there. So actually this Python interface is used to train the model, and on the basis of this training we can do prediction. So actually you can do for yourself to take this image as input, but for that you have to use two programs. One is having this whole code, and you can make your own module, and in the another program you can use this whole module to test with the images, but that is not user friendly. So mostly when we do any research work, or when we want to implement these algorithm for any use cases, we are mostly using the front end and back end both. Okay, which is more efficient, using images or input or CSV file? Actually, it totally depend on you, that which type of data set is available with you for a different use cases. For example, in the medical field, mostly the data set in the form of the images. But for example, if we are doing any making any recommendation system, in that cases we have data in the form of the CSV file also. Actually, the processing of the images is difficult, and it takes lots of time as compared to the CSV file. The size of the CSV file is very small, so the processing is fast. So if you have both the data set, image and CSV file, it is recommended to use the CSV as compared to the images, because the processing of the algorithm is fast. Okay. Yes, we can use RNN also. Yes, time series. In the tomorrow session, I want to cover you the LSTM for predicting the stock prices. Okay, but in today's session, I am going to cover this RNN for the sentiment analysis. Okay, so I'm just give you an overview that how to do that. So I am using this IMDb data set where there are lots of the data set data is available that is in the form of the text, and we have to do the sentiment analysis on the basis of the text. Okay. So here I make a size of the vocabulary, that is a number of words how we can process. I make this 10,000. You can use your vocabulary size as per your requirement. Now we have to load this data set. So I load this data set, and here how many data set I want to load. So I load 10,000 data set from this IMDb dataset. If you want to load full whole dataset, you don't want to use this variable, and here you have to make this blank. Means you don't have to pass any parameter. But this size is very large, so processing is requires a lots of time. So that's why I am making a fixed number of size, means how much data I want to use for the process. Okay. Now, uh, you know that when we are dealing with the uh, sentences that have the variable length, so we have to make uh, the all the sentences having the equal length, and for that, if the size of the sentence or the length of the sentence is less, in that cases we have to do the padding. So here I take the sentence maximum size is a 200, means 200 characters are there. And on the basis of that, I uh, make a padding in the training and testing data set. Means if the training data set size is less than 200, so make it 200. And if the testing data set sizes are less than 200, so make it 200. But it is required that all the data set all the sentences that we are using having the same length. Okay. Now we have to create our own RNN model. Again, in RNN, there are three layers. One is a input layer, second is a hidden layer, and third is a output layer. Okay, so here what I am using for making the input layer, I am using the embedding method, and here I pass the number of words. So how many number of words? We have 10,000 number of words. From that, we have to make a 32 notes, and the length of the input means how many how means which size of length of sentence is allowed in the input layer, that is a max length, that is a 200 characters. Okay. Now I am making a here I already explained you in the PPT that there are various varieties of the RNN is available, like simple RNN, vanilla RNN, LSTM. So I am using here a simple RNN with the 64 hidden layers. Okay. And as a return means output, I required only one layer. Okay. Means either it's true or it's false. Okay. Now similarly as in CNN and ANN, we have to create the model and we have to fit the model. And for fitting the model, we have to pass the training data set, and for validating or finding the testing, we require a testing data set. And here you can set it was as per your requirement. And here I calculating the accuracy of the algorithm. Now, if I run this code, you can see here it first download the data set. So the size of the data set is large, so it might be possible it takes time. Actually, this is not the case. Means I am not explaining you the code where we have to find the text similarity. This is not similarity, this is a sentiment analysis. And actually when we run the model or the create the model, it takes the data set size having the equal size. So padding is nothing, just simply adding the zeros or the null characters in the data set. So after means after adding the add the pad in the in the sentences, the data is not changed. Okay, so don't worry about that. But as we are using a we are going to use a inbuilt models, so it is a requirement that the sentences that we pass in the model having this equal length. I will surely tell you in the tomorrow session that what are the different library, because I have not done this extraction in the Python, but yes, I have done these programs in the R program. Okay, and if I found this code, then I also give you a code, so you can directly run with your data. Actually, there are lots of the methods available to find that which features uh, are helpful to improve the accuracy. Actually, when we are processing the data set and the layers that are used in the CNN and RNN filter the parameter, how they filter the parameter? They filter the parameter on the basis of the correlation between the parameter. Okay, so if the parameters or the column values that are interrelated with each other, it means changing in one affect in other. Okay, in that cases it only choose the parameters that is that having the more similarity. And if the data set in the column having the less similarity, in that cases that parameters are removed. So there are lots of the algorithm like PC algorithm, principal component analysis, and that is also based on the correlation, and on the basis of the correlation it filtered the parameters. Actually we cannot develop a code where the output is in the form of the image. Output is always in the form of the text. But yes, in the input we can take a image. But actually, in the as computer understand, the input is converted into a matrix, into a textual value only. I already explained you in a yesterday session that when we pass the image as an input, the computer what thing computer doesn't know what this image is, because computer only understands 0 and 1. So in that case it converts the image in the form of the matrix. Okay, so we can do a code where we can take image as an input, but we cannot able to uh, develop a code where the output is in the form of the image. Actually, this IMDb data set is not in the format that we can see. Okay, because this is a data set that is in the form of the binary files. In that case, for this reason, you can find only one record with the Y value. Okay, Actually, this whole data set is included in the Python, and this is a data set in the GBs. Okay, and that is not available for the users, and actually that is in the form of the folder. If I want to extract if you not find in Kaggle, then please find in the GitHub. It might be possible you get the whole data set. And I will also try, if I get, I will show you in the next session. 1 minute, I am sharing the. Okay, hope you receive the code. And I am also going to share you a one CSV file for the RNN. Please try to run, to make the changes and run this RNN for this sample data set also.